Hello friends, now we'll start the next exercise 6.2. Exercise 6.2, first example. If f of x is equals to 3x plus 5 and the g of x is equals to 6x minus 1, then find in bracket f plus g x. That is, we want to find out the sum of the functions. That is, in bracket f plus g of x. Now what is f of x? F of x is equals to 3x plus 5. And what is the g of x? G of x is equals to 6x minus 1. Therefore, now we have these are the two given functions. Now their sum is, now this is the sum, f of x plus g of x is equals to, that is a 3x plus 5 plus 6x minus 1. 3x plus 5 means what? 9x. 5 minus 1, that is 4. Now we will find there. This is the f plus g of x is equals to 9x plus 4. Second, their subtraction. Now we'll find out their values. That is f of 2 minus g of 2. Write their respective function and replace x by 2. Then we will get the answer. Now here is a 3x plus 5. That is, x is replaced by 2. And g of x is equals to 6x minus 1. Here is x is replaced by 2. And we find out their values. Therefore, in this way, 6 plus 5 minus 12 minus 1. Then you will get 11 minus 11, that is equals to 0. And third, f of g, their multiplication. That is f of 3 into g of 3. The value of f of 3 is, that is, again x is replaced by 3. Then you will get 3 into 3 plus 5, 6 into 3 minus 1. Therefore, 9 plus 5 in first bracket, second bracket 18 minus 1. 9 plus 5 is 14 and 18 minus 1, that is a 17. Therefore, their multiplication is 238. Now next is their fraction, that is f upon g of x, and it's a domain. Now f upon g of x is equals to f of x upon g of x, that is a 3x plus 5 upon 6x minus 1. This is f of x upon g of x. Is that is f upon g of x is not defined when x is equals to 1 upon 6. That is the denominator should not be 0. Therefore, 6x minus 1 is equals to 0. Therefore, 6x is equals to 1 and x is equals to 1 upon 6. That is a domain of f upon g. X is such that x belongs to set of real number and x is not equals to 1 upon 6. Number 2. Let f245 to the 236, this is a function, and g is defined 236 to 24, be given by f, that is the image of 2 is 3, image of 4 is 6, image of 5 is 2, and G is defined 2 to like this. Image of 2 is 4, image of 3 is 4, image of 6 is 2. Write down the GOF. Now first we'll write the function, that is image of 2 is 3, image of 4 is 6, image of 5 is 2, and the image, then function G, their order pairs. G of 2 is 4, G of 3 is 4, G of 6 is 2. Therefore, GOF of the 2 is f of 2. What is f of 2? F of 2 is 3. F of 2 is 3. And what is it? G of 3, and G of 3 is 4. The value of G of 3 is 4. Here is G of 3 is 4. G of 3 is 4. But what is f of 2? F of 2 is here. F of 2 is equals to 3. We replace f of 2 by 3. And G of 3 is 4. Now again, GOF of 4. Then we will have, that is f of 4. We'll find out the value of f of 4. The value of f of 4 is 6. And the G of 6 is 2 here. G of 6 is 2. GOF of 5. G of f of 5. What is f of 5? F of 5 is 2. It is given. And G of 2 is 4. Therefore, we have their order pairs 2 to 4, 4 to. Again, see this. We have, that is a 2. The composite function is 4. 4 has 2 and 5 has 4. In this. Now next, question number 3. If f of x is equals to 2x square plus 3, g of x is equals to 5x minus 2, then find FOG, that is FOG of x is equals to g of x. And what is the g of x? That we substitute. G of x is 5x minus 2. It's given. Now we'll find out the f of 5x minus 2. But what is our function? That is a 2x square. That is a, whatever that bracket square plus 3. F of x is a 2x square plus 3. But what is here x? X is 5x minus 2. Therefore 2 in bracket 5x minus 2 bracket square plus 3. And now expand it, plus 3. Simplify it. Then you will get the correct answer. And in this way, this is the FOG of x. Now next is GOF. Now here first G of f of x. But what is our f of x? F of x is 2x square plus 3. Now next is, what is the g of x? G of x is a 5x minus 2. That is a 5 into 2x square plus 3 bracket complete minus 2. And now simplify this. Then you will get the correct answer. That is a 10x square plus 30. Now next is see FOF. FOF means what? F of x. But what is f of x? F of x is 2x square plus 3. Again, f of 2x square plus 3 means what? 2 in bracket 2x square plus 3 bracket square plus 3. Whatever this x, it's a 2 in bracket square bracket 2x square plus 3 bracket square plus 3. Now expand this. That is a 2 in bracket 4x raised to 4 plus 12x square plus 9 plus 3. And after simplification, you will get 8x raised to 4 plus 24x square plus 18x plus 3. That is a 8x raised to 4 plus 24x square plus 21. This is a FOF of x. Now next is D GOG. That is a GOG of x is equals to G of Gx. Gx is 5x minus 2. That is a 5 in bracket 5x minus 2 minus 2. This is our G of x. What is the G of x? Whatever the here quantity, it's multiplied by 5 minus 2. And now the simplification. That's a 25x minus 10 minus 2. That's a 25x minus 12. Now question number 4. Verify that f and g are inverse function of each other where f of x is equals to x minus 7 upon 4 and g of x is equals to 4x plus 7. Now to show that the given functions are inverse of each other, that is f and g both are 1, 1 and onto functions such that f of g of x is equals to x for every x belongs to domain of g, and g of f of x is equals to x for every x belongs to the domain of f. Then g is called the inverse function of x. G is called the inverse function of f. Function g is denoted by f inverse of x, and f of g of x is equals to g of f of x, and that is equals to x. Then g is equals to f inverse of x, which means f of f inverse of x or f inverse of f of x is equals to x. Now we'll start the example. Now f of x is equals to x minus 7 upon 4 and g of x is equals to 4x plus 7. Now we'll find out FOG, that is f of g of x, that is equals to f of 4x plus 7. But what is our function f of x? Our function f of x is x minus 7 upon 4. Therefore, whatever the quantity here, that is a 4x plus 7 minus 7 upon 4. And if we simplify it, you will get 4x upon 4, which is equals to x. Therefore, f of g of x is equals to x. Now next we will verify g of f of x Therefore, what is our f of x? Our f of x is x minus 7 upon 4. And what is the g of x? That is the g of x is equals to 4x plus 7. That is whatever the quantity here, it's multiplied with the 4 and add with 7. Then you will get 4 in bracket x minus 7 upon 4 bracket complete plus 7. And after simplification, you will get x minus 7 plus 7, that is equals to x. Therefore, g of f of x is equals to x. Therefore, from 1 and 2, f of g of x is equals to g of f of x is equals to x. And hence, f and g are inverse functions of each other. Now next is f of x is equals to x cube plus 4 and g of x is equals to cubic root of x minus 4. Now we'll find out f of g of x. But what is the g of x? G of x is cubic root of x minus 4. Now we'll find out there f of x. F of x means what? X cube plus 4. It means that whatever the quantity here, make its cube and plus 4. Therefore, next you will get, what is here? Here is cube of cubic root of x minus 4. It becomes, that is 3 get cancel here. We get x minus 4. That is the cube of cubic root of 4 is nothing but the x minus 4 plus 4, and overall you will get x that is equals to 4. Sorry, it's by mistake. That is equals to x. Therefore, f of g of x is equals to x. Now next is g of f of x. But what is f of x? F of x is x cube plus 4, and therefore you will get g of x is cubic root of x cube plus 4 minus 4, and you will get x, and that is equals to x. Therefore, g of f of x is equals to x, and g of f of x is equals to x, and f of g of x is equals to x. Therefore, from 1 and 2, both are inverse of each other. Therefore, f and g are inverse functions of each other. Now see, f of x is equals to x plus 3 upon x minus 2, and g of x is equals to 2x plus 3 upon x minus 1. Therefore, f of g of x is equals to f of 2x plus 3 upon x minus 1. Therefore, 2x plus 3 upon x minus 1 plus 3 upon 2x plus 3 upon x minus 1 minus 2. And after simplification, it is multiplied by x minus 1 is multiplied with the 3 divided by x minus 3. This is the simplification. This is x minus 1 is multiplied with 3. That is a 3 in bracket x minus 1. Now whole divided by x minus 1. Now the denominator will apply the same trick. That is a 2x plus 3 minus 2 in bracket x minus 1 upon x minus 1. That is x minus 1 get cancel. And after simplification, you will get 5x upon, therefore x is equals to 5x upon 5, therefore equals to x. Therefore, f of g of x is equals to x. Now we'll find out g of f of x. What is the f of x? F of x is x plus 3 upon x minus 2. Now, what is the g of x? That is a 2 times whatever that x plus 3 upon x minus 1. That is a whole bracket minus 1. Now, their simplification. This is a x minus 2 into 3. That is x minus 2 into 3 upon divided by x minus 2. And to the denominator, x plus 3 minus in bracket x minus 2 whole divided by x minus 2. Therefore, these get cancelled. And after simplification, you will get that is equals to x. Therefore, g of f of x is equals to x. This is number 2. And that's why from 1 and 2, both of them have the same values. And hence, f and g are the inverse functions of each other. Now the next question, question number 5. Check if the following functions have an inverse function. If yes, find the inverse function. Now first of all, again the definition of the function. If a function from a to b is 1, 1 and on to function, then corresponding to every element of b, we can find a unique element of a which defines a function from b to a called the inverse of the function f. Now you can see this here, the definition. Inverse function of f. That is, the every element of the b has a unique preimage which defines a function from b to a called the inverse function of f. F inverse of b to a. F inverse of from the b to a. Every element of b has a unique element in a also. Now we'll see through the examples also. If a function defined from a to b is 1, 1 and on to, and g is defined from b to a is also 1, 1 and on to, such that g of f from a to a and f of g from b to b are both identity functions for all x is in a, then f of g of y is equals to y for all y is in y. That is, I am writing the definition. Then f and g are called as inverse function of each other. This is another definition for the inverse function of each other. These are the two different definitions. Now check if the following functions have inverse function. If yes, find the inverse function. F of x is equals to 5x square. Now here if we find out f of 3, what will happen? F of 3 is equals to 5 into 3 square, and that is equals to 5 into 9, that is equals to 45. F of minus 3 is equals to 5 into minus 3 square, that is 5 into 9, that is equals to also 45. That is f of 3 is equals to f of minus 3, but 3 is not equals to minus 3, therefore f is not 1 1, therefore f inverse does not exist. In this case, f must be 1 1 and onto. In this problem, in the given problem, that is the image of 3 and the minus 3 both are the same, but 3 is not equals to minus 3, therefore f is not 1 1 and hence f inverse does not exist. In second problem, it's a constant function. F of x is equals to 8. What about the f of 3? F of 3, f of minus 3, that is also 8. Now again, the 3 and minus 3 has the same image. Therefore, again the given function is not 1 1. 3 is not equals to minus 3. Therefore, f is not 1 1. To show that the given function has an inverse, that is, we want to prove that the given function is 1 1 as well as it must be onto. Then we say that the inverse of the given function exists. Now in this case, in these two cases, we check first of all, is there 1 1 relation? No, there is not 1 1 relation. That's why we say that the given function do not exist the inverse of the function. F inverse does not exist. Now next see, f of x is equals to 6x minus 7 upon 3. Now in this case, we'll take, that is, f of a is equals to f of b. Suppose that. Then what will happen? 6a minus 7 upon 3, 6b minus 7 upon 3. And if you simplify it, then we will get a is equals to b. That is, f of a is equals to f of b. Then we get a is equals to b. It means that if a is equals to b, then their images are also equal. That is, f of a is equals to b. Therefore, it implies that a is equals to b. What we started from f of a is equals to f of b, and then we get a is equals to b. It means that the given function is 1 1. Now we'll prove that is y is equals to f of x. Suppose that 6x minus 7 upon 3 is equals to, and now after simplification, find out the value of x in terms of the y. That is, the 3y is equals to 6x minus 7. Therefore, x is equals to 3y plus 7 upon 6. Therefore, for every y is in R, we have x is in R such that for every y in R, we have x is in R such that f of x is equals to y. Therefore, f is onto. For every y in R, we have x is in R such that f of x is equals to y. Therefore, this is the definition of the onto. Therefore, f is onto. Therefore, f is 1 1 as well as it is onto, and hence f inverse exists. Now, f inverse of y is equals to. Now, what is there? The f of x is equals to y. Then what is f inverse of y? F inverse of y is x. If and only if f of x is equals to y. Therefore, f inverse of y is equals to 3y plus 7 upon 6. that is replaced by y by x, then f inverse of x is equals to 3x plus 7 upon. Now see this again. F inverse of x is equals to 3x plus 7 upon 6. Now next is D. F of x is equals to in root of 4x plus 5. That is the square root is always positive. Is always positive. Therefore, if f of x is equals to y, then y is equals to in root of 4x plus 5. Therefore, the value of y is always greater than or equal to 0. But suppose that if y contains a negative number, that is the range is, what is the range? The range is always from 0 to infinity. That is, if y contains a negative number, that is for negative value of y, we cannot find x such that y is equals to f of x. If y has any negative number, we cannot find y such that y is equals to f of x, and hence f is not onto. Therefore, f inverse does not exist. Therefore, our definition that if the given function is 1, 1 and onto, then f inverse exists. It is not the 1, 1 onto, and hence f inverse does not exist. Now next is f of x is equals to 9x cube plus 8. Here firstly we will show that f is a 1, 1. Again f of a is equals to f of b. To show that we can write it like this. That is a 9a cube plus 8. 9b cube plus 8. After simplification, you will get a is equals to b. Therefore, it implies that f of a is equals to f of b. It implies that a is equals to b. Therefore, f is 1, 1. Now we will show that it is onto. Let y is equals to f of x is equals to 9x cube plus 8. Now simplify this and find out the value of x in terms of y. That is the y minus 8 is equals to 9x cube. Therefore, x cube is equals to y minus 8 upon 9. Therefore, x is equals to cubic root of y minus 8 upon 9. Therefore, for every y is in R, we have x is in R. For every y in R, we have x is in R. We get the cubic root such that f of x is equals to 1. And hence, f is onto. And hence, f inverse exists. That is f inverse of, that y is equals to f inverse of y is equals to x. And therefore, f inverse of y is equals to, that is a cubic root of, and f inverse of x, we will replace y by x. Therefore, f inverse of x is equals to this. Again, you can see this answer. F inverse of x is cubic root of x minus 8 upon 9. Now, next, f of x is equals to x plus 7 when x is less than 0, and 8 minus x where x is greater than or equal to 0. Now, in this case, for x is less than 0, now we will take x is equals to minus 1. If we take x is equals to minus 1, what is a f of x is defined such that x plus 7 where x is less than 0. In this way, we can take the value of x is minus 1, minus 2. And suppose if we take x is minus 2, then what will happen? We'll find out its image, its value. F of x is equals to x plus 7. Then what is f of minus 2? F of minus 2 is 5. That is a minus 2 plus 7. That is equals to 5. And for the second function, and if we take f of x is equals to, that is x is greater than or equal to 0. And in this case, if we take x is equals to 2, then what will happen? Sorry, x is equals to 3. Then you will have again the same image, that is equals to 5. Now f of minus 2 has the image 5 and f of 3 is also 5. Therefore, 2 is not equals to 3 and f is not 1, 1, and hence f inverse does not exist. Now next, question number 6. Now next problem is f of x is equals to x cube plus 3, where x is less than or equal to 2, and f of x is equals to 5x plus 7, where x is greater than 2. Find out the value of f of 3, f of 2, and f of 0. Now first we'll find out the value of f of x is equals to 5x plus 7. Now here the x is equals to 3, therefore we take the second function, that is a 5x plus 7. This is defined when x is greater than 2. And our value x is 2, x is 3, therefore we take the function 5x plus 7, and hence x is replaced by 3. Therefore the value is 5 into 3 plus 7, that is a 15 plus 7, that is equals to 22. F of 3 is equals to 22. F of x is equals to x square plus 3. Now in this case, the value of x is less than or equal to 2, and hence we take the first function, because we want to find out the value of f of 2, that is a 2 square plus 3, that is a 4 plus 3, and that is equals to 7. Now see, f of x is equals to x square plus 3, and x is less than or equal to 2, and in this case our value is 0, therefore we take the function f of x is equals to x square plus 3. Therefore f of 0, x is replaced by 0, that is a 0 square plus 3, and that is equals to 3. Therefore f of 0 is equals to 3. Now the 7. If f of x is 4x minus 2, for the value of x is less than or equal to minus 3. F of x is equals to 5 for the value of x lies between minus 3 and plus 3 and equals to x square. The value of x is greater than or equal to 3. Now find out the value of f of minus 4. Now to find out the f of minus 4, we'll take the value of x such that which are less than minus 3. Therefore we take the function 4x minus 2, because our x is minus 4, and hence that is equals to f of x is equals to 4x minus 2. Here x is less than or equal to minus 3. Therefore, x is replaced by that is equals to minus 16. That is equals to minus 18. Now next is f of minus 3. To find out the value of f of minus 3, again we take the same function. That is f of x is equals to 4x minus 2. X is replaced by minus 3. That is a 4 into minus 3 minus 2. That is a minus 12 minus 2. That is a minus 14. Therefore, f of minus 3 is equals to minus 14. Next is f of 1. Now, to find out the value of f of 1, we take the middle function, that is f of x is equals to 5. Because in this case, the range is x lies between minus 3 to the plus 3. In between minus 3 plus 3, we get minus 2, minus 1, 0, 1, 2. And hence f of 1 is equals to 5. Now next is f of 5. F of 5, f of x is equals to x square for x is greater than or equal to 3. Therefore, our value of x is 5. And therefore, we take the function f of x is equals to x square. That is the third function. And hence, f of 5 is equals to 5 square, which is 25. Now next is question number 8. F of x is equals to 2 mod of x plus 3x. Then find the value of f of 2, f of minus 5. Now in this case, to find out the f of 2, that is f of 2 is equals to 2 into modulus of 2 plus 3 into 2. That is mod of 2 is 2. 2 into 2, 4. Here is 4. Plus 3 into 2, which is 6. That is equals to 10. Therefore, f of 2 is equals to 10. Now next is f of minus 5. Therefore, f of x is equals to 2 mod of x plus 3x. Now here x is replaced by minus 5. That is equals to 2 into mod of 5 plus 3 into minus 5. But what is the mod of 5? Is plus 5. That is a 2 into 5. That is equals to 2 into 5 minus 15. That is a 10 minus 15. That is equals to minus 5. And f of minus 5 is minus 5. Now next is question number 9. That is f of x is equals to 4 into the greatest integer function minus 3. Now here we read it is like this. F of x is equals to 4 in square bracket. It means that the greatest integer of x minus 3. Now see this here. Then find f of 7.2. What is the definition of the greatest integer function? That is, for every real x, f of x is equals to the in square bracket x. It means that the greatest integer less than or equal to x, or if x belongs to R, then the greatest integer not exceeding x, it is denoted by the greatest integer of x. For example, if we take f of 5.7, then its a value is equals to 5. That is, we take the integer function. We take the integer and not the fraction. Now, what is the greatest integer of 2.05? is 2. Greatest integer of minus 6.7 is minus 3. It is a greater than, that is equals to minus 7. Next is, it is minus 3. Less than or equal to. F of 2 is 2. F of pi. The value of pi is 3.14. That is equals to 3. The value of e, that is a 2.73. Therefore, we treat it as e. That is the greatest integer of e is equals to. Therefore, f of 7.2, f of x is equals to 4, greatest integer of x minus 3. Therefore, we take the greatest integer of 7.2. Now, what is the greatest integer here? Is 7. That is 4 into 7 minus 3. That is equals to 28 minus, sorry, it is a 28 minus 3, and that is equals to 25. Now, see this again. That is a 28 minus 3, that is equals to 25. This is the answer. Now next is B, f of 0.5. Now again f of x is equals to 4 into greatest integer of x minus 3. Now f of 0.5, that is a 4 in bracket greatest integer of 0.5 minus 3. Now what is the greatest integer? Is the 0. That is a 4 into 0 minus 3. That is equals to, overall it is a minus 3. That is f of, this is answer. Now next is C, f of 5 upon 2. That is again 4 greatest integer of minus 5 upon 2 minus 3. Now see this here. That is a 4 minus 2.5. Now what is the greatest integer here? Is a minus 3. 2 into minus 3. This is very important. Minus 2.5. Its a greatest integer is minus 3. Minus 2. By mistake I had written is 2, but here is a 3. I will replace it. This is the answer. You can write now. Therefore, f of minus 5 by 2 is equals to minus 15. Now next D is f of 2 pi. Therefore, f of 2 pi is equals to 4 in bracket. This is our function, and 2 pi means 3.14 into 2. That is 4 in bracket 6.28 minus 3. Therefore, the greatest integer of these is 6.20 is 6. Integer. We require the integer always. That is 6. Therefore, their multiplication is 24 minus 3. Therefore, f of 2 pi is 21. Now see this again. Answer. That is equals to question number 10. If f of x is equals to again the f of x is equals to 2, that is a fraction part of x. In curly bracket, this denotation treat as the fractional part of x plus 5x. Where in curly bracket we treat as fractional part of x. Then find f of minus 1. Now see this our function. F of x is equals to 2 in curly bracket of x plus 5x, where curly bracket of x is equals to fractional part of x. Means what? Here we take our function x, the value of x. What about here? The integral part of x. Then after subtraction, you will get the fractional part of the x. It's very simple. Now see this here. That is f of x is equals to, what is the value of this curly bracket? That is the fractional part of x is equals to x minus integral part of x plus 5x. Now see this again. If we simplify here, 2 into x minus 2 into integral part of x plus 5x. Again simplify it. You will get 7x minus integral part of x minus 2 into integral part of x. Now again f of minus 1. Therefore 7 into minus 1 minus 2 in bracket the integral part of the minus 1, that is equals to minus 2 into minus 1, and therefore that minus minus will become plus, and hence minus 7 plus 2, that is equals to minus 5. This is answer. Now next, f of 1 upon 4, that is f of our function is 2, that is a fraction, 2 into fractional part of x plus 5x, that is a 2, the fractional part of 1 upon 4 plus 5 into, this should be not there, it's by my mistake, that is a 4, that is a 5 into 1 upon 4, curly bracket should not be there, fractional part not recorded there. Add, change it, and replace the fractional part of 1 upon 4 means what? That is a 2, this is 2 is as it is, in bracket 1 upon 4 minus integral part of 1 upon 4 plus, what is here? 4 into 1 upon 4. This bracket should be not there, but my mistake, I had written here, but now I had clear here. That is a 5 into 1, that is a 5 upon 4. Now this is the fractional part of x. The definition of fractional part of x is x minus integral part of x, that is 1 upon 4 minus integral part of 1 upon 4. Now see this simplification, that is a 2 in bracket 1 upon 4 minus integral part of this is, that is 1 upon 4 means what? 0.25, and 0.25 its integral part is 0, therefore I had written is 0. This is very important. Integral part of 1 upon 4, 1 upon 4 is 0.25, and integral part of 0.25 is 0 plus 5 by 4, and after simplification you will get 2 upon 4 plus 5 upon 4, that is equals to 7 upon 4 and equals to 1.75. Now next is, see, f of minus 1.2. Now what is our function? 2, the fractional part of x plus 5x, where the fractional part is equals to x minus integral part of x. Therefore f of x is equals, f of minus 1.2 is equals to 2 minus the, that is a fractional part of minus 1.2 plus 5 into minus 1.2. See this, our simplification is here, that is a x minus, this is our x, which is minus 1.2 minus fraction part of 1.2, bracket complete, multiplication 5 into minus 1.2, and that is equals to 6. Therefore minus 1.2, and what is here? The integral part of minus 1.2. Now again see this here, it's a fraction, and therefore the integral part of, whenever there is a fraction, the integral part of is again the minus 2 here. That is less than that quantity. Therefore this is important. And after simplification, you will get 2 minus 1.2 plus 2 minus 6. And therefore, there is a 2 into 0.8 minus 6. And after simplification, that is 1.6 minus 6. Therefore, 4.4, which is the answer. Now, next is D, f of minus 6. Therefore, f of x is equals to 2. The fractional part of x plus 5x. Again, the fractional part of x is equals to x minus integral part of x. Therefore, f of minus 6 is equals to the fractional part of minus 6, 2 into fractional part of minus 6, plus 5 into minus 6, and you will get the answer. That is the fractional part of minus 6 is minus 6 minus integral part of minus 6. Now their multiplication, 5 into minus 6, which is the minus 30. Therefore, what is the integral part of minus 6 is treated as minus 6, and therefore this minus minus will become plus 6, and minus 6, that overall it will become 0, and answer is minus 30. Therefore the answer is minus 30. You can see this here. We're going to see. That is equals to, you can see this, that is equals to minus 30. This is the answer. We'll start the last question. Question number 11. Solve the following for x where mod of x is, that is the modulus of x, modulus function, greatest integer function, and the fraction part of x part function. The first is mod of x plus 4 greater than or equal to 5. Now to solve this, if we eliminate the element, that is a plus or minus sign we get here, that is the mod of x plus 4 greater than or equal to 5. Then x plus 4 greater than or equal to 5, or x plus 4 less than or equal to minus 5, and simplify here. To simplify here is a 4. We want to find the value of x. Therefore, subtract on both sides by minus 4. Here to find out the value of x, minus 4 on both sides, here also minus 4 on both sides, and that's why you will get x is greater than or equal to 1, or x is less than or equal to minus 9. Therefore, x is greater than or equal to 1, means 1 is included, or x is less than or equal to minus 9. That is, x is less than or equal to minus 9. It means that x belongs to minus infinity to plus 9. It is less than or equal to, therefore closed bracket is here. Here is a greater than or equal to, means 1 is included. It means that the value of x is equals to 1 and greater than 1 up to the infinity. Here is a x is less than or equal to minus 9. It means that the value of x is equals to 9 and less than minus 9, means what, up to the minus infinity. Now next is B, that is mod of x minus 4 plus mod of x minus 2 equals to 3. Here we have the different possibilities. That is, here is a mod of x minus 4 plus or minus x minus 4 plus or minus x minus 2, that is equals to 3. Now we have the 4 different possibilities here. That is case 1, both of them are positive. and simplify it. If you simplify it, then you will get, now this is normal simplification, x plus x is 2x, minus 4 minus 2 minus 6 equals to 3, and that's why 2x is equals to 9. Therefore x is equals to 9 by 2, which is 4.2. Now case 2, both of them are negative, and simplify it. Then you will get, after simplification, see this, minus and minus minus here, plus 2, minus 4 here becomes a plus. Therefore minus 2x plus 6 is equals to 3. Therefore minus 2x, that is equals to, minus 2x is equals to 3 minus 6 here equals to minus 3, and the value of that x is equals to minus, that is equal, value of x is equals to 1.5. Next is case 3. Now one is positive, another is negative. In this case we take this first is positive, second is negative, and simplify it. Then you will get plus x minus x get cancelled, and we get the minus, that is, sorry, it is a plus 2, that is 2 is equals to 3, but it is not possible. By mistake I had written, what is here, that is, sorry, minus 4 plus 2. After simplification, minus 4 plus 2 will get the minus 2, and that is equals to 3, which is not possible. Therefore we not consider this case. Case number 4, first we take the negative, second it is a positive. Therefore minus x plus 4 plus x minus 2, that is equals to 3, minus x plus x, again we will get, that is a 2 is equals to 3, again it is not possible. Again this case will be not possible, 2 is equals to 3 is not possible, we not consider this case, not possible. Therefore the value of x is equals to 4.5 or 1.5. This is the answer. Now again see this, this is the answer. Now next is x square plus 7 mod of x plus 12 equals to 0. Now case 1 is when mod of x is greater than or equal to 0. Therefore in this case mod of x is equals to x. Equation, that is a, here we will solve this quadratic equation, x plus 4 in first bracket, second bracket x plus 3 equals to 0, x plus 4 is equals to 0 or x plus 3 is equals to 0, x is equals to minus 4 or x is equals to minus 3. But x is greater than or equal to 0, therefore there is no solution. We have treated as x is greater than or equal to 0. Now second case, x is less than 0. That is a mod of x. When x is less than 0 means what? X is negative. That is a mod of x is equals to minus x, and that's why our equation 1 becomes, that is x square minus 7x plus 12 is equals to 0, and this is the normal simplification. X minus 4 into x minus 3 equals to 0. This is quadratic equation, and the value of x is equals to 4, x is equals to 3. Now next is, but x is less than 0, therefore again there is no solution. We have treated as x is negative, therefore the equation has no solution. Therefore the solution set is empty. It is fine. Now D is, mod of x is less than or equal to 3. Then we have the possibilities. Mod of y is less than or equal to, then when the value of y lies between minus n to plus n. In this case same, this thing is here. The value of x lies between minus 3 to the plus 3. and that's why x belongs to the closed interval -3 to +3. It doesn't matter. That's the 2 times mod of x is equals to 5. That's the mod of x is equals to 5. It means that x is a plus or minus 5. And simplify this. If we simplify it, that's a plus or minus 2x is equals to 5. Therefore, 2x plus 2x is equals to 5, or minus 2x is equals to 5. Therefore, x is equals to 5 by 2, or x is equals to minus 5 by 2. And therefore, you will get x is equals to plus or minus 5 by 2. That is, x is equals to plus or minus 2.5. Now, next is f x. Now, see this here. That is the integral part of x plus integral part of x plus integral part of x, and that is equals to 9. Now, see this case 1. Let x be the integer. Then we write its first is, again we see this as x is integer. Then we treat it as integral part of x is x. Therefore, every time we write it, in this case x is integer. Therefore, the integral part of x we write here x. Then we will get 2x. Then again integral part of 2x is 2x plus x. Then we get the 3x in this way. Now see this here. This is important. Integral part of x is integer. Therefore, integral part of x is x only. Now, in the next step, we add these two. Then you will get 2x. Okay. After getting the 2x, but what is the meaning of this? Meaning of this is integral part of this 2x. Therefore, its value is again 2x. Now, see this again here. Here is x plus x is 2x. Now, we require the integral part of this 2x. Integral part of this 2x is 2x. See this here. Yes, integral part of this is 2x. Now again, x plus 2x is 3x. And what is the integral part of 3x? Integral part of 3x is 3x, and that is equals to 9. See this again here. This is the 3x. Their addition, normal addition is there. That is equals to 9. Now what is the integral part of 3x? Is 3x, and that is equals to 9, and hence x is equals to 9 upon 3, that is equals to 3. Therefore, x is equals to 3. This is the answer. Now, next is case 2. X be any real number. X be any real number which is not integer. That is, it is a fraction. That is, the value of x lies between. X belongs to z. It is integer, and it lies between n and n plus 1. Then what will happen there? That is, it is a fraction. N is unique. Therefore, integral part of n, this is n. The answer will be the n, integral part. It is always less than or equal to, but here we will take the less than. And that's why integral part of x is n. Therefore, the equation becomes, now see this here, that is equals to integral part of x is n. This is n, integral part of, this is integral part. This is n, and next is integral part of, now this is, now again the integral part of this is x is also n, and n plus n, that is a 2n. Now next is also 3n. Integral part of x is also n, that is a 3n, and in this case we get 3n is equals to 9, n is equals to 3. Therefore, it's very clear that x is a greater than 3 and less than 4. means the value of x lies between 3 and 4. Therefore, x is equals to 3 plus r. It may be 3 plus r. And where the value of r lies between 0 to 1. This is important because the value of x is greater than 3 and less than 4. Means it is some fractional part. And therefore, from 1 and 2, we have that x is equals to 3 plus r, where the value of r lies between 0 and 1. Actually, this is tough one, but you have to remember. Now, the next is g. That is a fractional part of x is equals to 4. That is a fraction is always rise between 0 to 1. Okay. Equal to 0, equal to 1 also. And the fractional part of that is a fractional part of x is a greater than 4 has a no solution. Therefore, the solution set is greater than 4, but it lies between 0 and 1, and therefore solution set is empty here. Next is fractional part of x is equals to 0. But what is the fractional part of x? The fractional part of x means what? That is x minus integral part of x, and that is equals to 0. Here's the definition of the fractional part. X is an integer, so the solution set is z. X is an integer, and integer belongs to the set of z, that is a set of integer. Now next is the fractional part of x is 0.5. It's no problem. Therefore, that is equals to 0.5. That was the fractional part of x by definition, that is x minus integral part of x, and that is equals to 0.5. Therefore, x is equals to, there will be integer, and it will be like this. That is the x is equals to n plus, that is the fractional part. Therefore, n belongs to z. This is the solution. If we subtract there, it may be integer like this, which belongs to this. Therefore, x is equals to n plus 0.5. Now, next is j. That is a 2 into fractional part of x is equals to x plus integral part of x. Now, we will simplify here. That is a 2 fractional part of x is equals to x plus integral part of x. Now, simplify here. What is the fractional part of x? That is equals to, it is written as like this. That is here the integral part of x. What is meant by this x? Integral part of x plus fractional part of x plus the integral part of x. Now here we will simplify here. That is a 2. If we simplify here, that is a fractional part of x is equals to 2. Then we will get here the integral part of x. And here is also integral part of x. That is, we get the 2 integral part of x. This bracket you don't take as a integral part. It must. Okay. Therefore, 2 times integral part of x. Now see this again step. That is a 2 times fractional part of x is equals to to integral part of x plus fractional part. Now on both sides, here is a fractional part and here is a 2 times. Therefore, only the single time remains on the left hand side, and that is a fractional part of x is equals to integral part of x, means this and this. This is the 2 times, and this one in fractional part get cancelled on from the both sides, and that's why the answer is, that is the value of x lies between 0 to 1, and but the 2 times integral part of x belongs to set of integers only x is equals to 0. Now this is very important. The fractional part is lies between 0 and 1, equal to 0, equal to 1. But what tells here to the right hand side? To the right hand side we have the 2 times integral part of x. Now this overall, this 2 integral part of x belongs to set of integers. Now when this condition will be satisfied, this is satisfied only when x is equals to 0, and that's why that is equals to x is equals to 0 is only the solution. And in this way we have completed the exercise 6.2. We'll see in the next video. Till then, goodbye.